Well, in this question, we are given with a particle having mass of 8 kg, and this particle is projected along this inclined plane, and the length of this inclined plane is x meter. And this inclined plane is making an angle of alpha with the horizontal, and the initial velocity of this ball or this particle is 5 meters per second, and its final velocity is 0. We are asked to find out the increase in the potential energy and increase in the kinetic energy, and if the motion of the particle is resisted by 15 Newton force, we need to find out the value of x, that is the length of this inclined plane. Now, first of all, increase in the potential energy. So let us suppose this is the first position of the ball, the initial position of the ball, and B is the final position of the ball. So we need to find out the potential energy at both these points in order to calculate the increase or change in the potential energy. So potential energy at point A will be mgh, and since height at A is 0, therefore potential energy will be 0. Now potential energy at B. Now potential energy at B, now this ball is at a certain height, this h, and we can calculate this height h in terms of alpha and x. Now we know that in this triangle, sine of alpha is equal to h over x, and by cross multiplying we can have h is equal to x into sine of alpha. Now potential energy at B will be m, g and h. M is given 8, g is 10, and h is this value x sine of alpha. Now this becomes 80x, and sine of alpha is 5 over 13, and this will become 400x over 13. So this is the potential energy at B. Now in order to calculate the change in the potential energy or increase in the potential energy, so this increase will be increase or change in potential energy will be equal to potential energy final as the potential energy at the position B minus potential energy at the position A. Now what is the potential energy at B? That is 400 x over 13, and initial is of course 0, so it will become 400 x over 13. So this is our increase in the potential energy. Now the second part is related with the kinetic energy. So again we will be finding in the kinetic energy at the point A and kinetic energy at the point B. Now at this point A, the velocity of the particle is 5 meters per second. So kinetic energy at the position A will be 1 over 2 mv square. Now v here is velocity is 5, so 5 square become 25, and we are also given with this value of m, and that is 8. So instead of writing m, we should be writing 8, and we should cancel this factor, and we are left with 100 joules, and this is also joules. And the kinetic energy at the position B will be again 1 over 2 mv square, but since velocity at point B is 0, therefore this whole term will be 0, therefore the kinetic energy at point B will be 0. So therefore the change in the kinetic energy, or the loss in the kinetic energy, will be the final kinetic energy, then the kinetic energy at the point B minus the kinetic energy at the point A, which is 100 joules, and this will become minus 100 joules. Now the third part is, if the motion of the particle is resisted by a 15 Newton force, find x. Now in order to solve this part, we will be using energy work relation, and that is increase in potential energy plus increase or change in kinetic energy is equal to the work done by the forces. Now here only one force, we are given with only one force, and that is of 15 Newton. So we need to find out the work done by this force, which is resisting the motion of the particle. Now since it is resisting the motion of the particle, therefore the displacement and its direction will be in the opposite side. So therefore the work done will be negative, and the work done, we know that it is the product of force and displacement, and it will become minus 15 force into displacement, and displacement we know that it is x, and we should write it here x. So this is the only work done here, because we have got only one force given in this question. There is no other force. So now we need to put the values. Increase in the potential energy. Now here we have got this potential energy, that is 400 x over 13, and then we have got what, plus that's kinetic energy, and kinetic energy is what, that's minus 100 joules, and that is equal to the work done by the various forces, and since we have got only one force, it is minus 15x. Now if you simplify this expression, you will get 30.8, and it will become minus, of course, x, and this minus 100, and this will become minus 15x, and this will become 30.8x plus 15x is equal to 100, and it will probably 30 or 40, 45 0.8x is equal to 100, and x will be equal to nearly 2.18 meters. So this is the value of x.